Hello everyone, this is Srikanth Vissarapu. I work as a software engineer at Meta. For this talk, I would be covering scalable MLOps pipelines that actually work. Essentially, what are some of the best practices that can help to move model development from model developed from lab to production essentially. The first we'll talk about the existing challenges. If you look at the global landscape, looks like we can see ML deployments are growing at a rapid pace, almost like 40% annually, or even probably more than that right now. And its success remains extremely low. So if you look at some of the statistics, you can say almost like 87% of the ML projects never reach production. A lot of them will die down much before experimentation phase or much before that. Even for the 13% of them which actually reach production, we can see that there are a lot of operational challenges, and eventually they may not deliver the success metrics that we want to see in production environments. Like it could be challenges around model drift, infrastructure bottlenecks, or even operational complexity of how we have built the whole pipelines. So, what would we be covering as part of this talk? I think this is a brief agenda of what we would be covering. First, we'll try to look at what is the existing state of enterprise ops, what does the current landscape look like, and we'll talk about what are the strategic ML ops architectures that we can look at, essentially all towards what are the efficient model development, deployment, management, continuous monitoring, and all those different aspects of it. The next important aspect is what are the implementation strategies that we can implement, mostly into technical solutions of how do we have a right methods in place for model validation, testing, ML workflows for seamless ML CI/CD deployment pipelines and all that. And the other important aspect is also like organizational transformation. It's not only about the tools, it's also about how do we organizationally function in such a way that all the teams like data science, engineering, and operation teams work together in collaboration to make this whole journey a success. And eventually, I think we'll also touch upon what are the emerging trends that we can look at so that we are building these pipelines or MLOps for the future. So the first thing, looking at what is the current state. We're just starting with that. There are two quadrants we can look at. One extreme is like purely manual, low maturity, and the other side is mostly like full automation, high maturity MLOps systems. Again, looking at the manual side of the things, essentially, if you look at, there are processes around starting from left bottom side is like limited pipeline automation, and from the left off, you can see, okay, but these are different systems we usually see in production, right? So mostly we'll start there. It can be like some systems can only be ad hoc experimentation, mostly manually. We just do some kind of experimentation, mostly manual, no automation, primarily engineers or scientists who are essentially building pipelines, testing them, and ad hoc as the core, right? And the other aspect is there could be minimal automation, limited pipeline automation for scheduled jobs, maybe like a small cron jobs or stuff like that. But that's about it. Mostly like manual and low maturity kind of models, right? If you look at high maturity and the other spectrum of it, the MLOps systems, right? Team specific MLOps systems. It can be like every team or every company has its own lot of internal tools. How do we deploy, package the models, deploy the models, and also test them. All those constructs are relatively different in terms of how companies adopt such methodologies. So having that consistent or having that repeatable workflow. So how do we all through this life cycle of model development, deployment, and testing, and all those aspects, how do you have that repeatable workflows is also extremely important. Having that is a maturity level of any MLOps systems in a way. And the other important aspect, we can also look at enterprise MLOps and a full automation, data driven, where we have metrics to capture at every stage of model deployment. When there is development, testing, and even deployment, we can have a lot of testing baked into at every phase of it. And eventually, looking at the metrics, we proceed with the model deployment or roll back or go to different versions and all those different aspects, which we will touch upon in a brief while now. Again, a similar aspect to it, just to elaborate on what I've been touching upon before, is the first level 0 is mostly about ad hoc experimentation. People just start with something new and also purely manual with no standardized workflows at all, and fragmented collaboration. People collaborating is also mostly fragmented in a way. And there is no desired metrics or success metrics defined, and model performance also lacks a lot, right? And the next level in terms of maturity is like pipeline automation. Now we don't have a lot of automation in place, then we come up with some kind of automation, the basic automation we can say, right? And even though we made some progress in terms of pipeline automation, there are still some lacking statements, things like we don't have really good governance frameworks. Teams are pretty siloed in a way, and also the monitoring is not robust enough to identify model drifts or all kinds of performance issues that we can see, right? That is a state of level 1 we can briefly talk about. Level 2 is like a little more advanced or matured kind of systems, is mostly continuous integration. We have standardized repeatable pipelines. You can bake in how you want to have a model go through the system to have a seamless or repeatable pipelines essentially, right? And also we have robust version control. Every model we put version to it and all that stuff. At the same time, automated testing extremely important. When we deploy a model, every phase having that automated testing is extremely important. It reduces a lot of manual effort. And also proactive, having that really sound monitoring is also extremely important in when we talk about enhancing this MLOps pipelines. And the next important thing, I think this is like the we have the best in class. You have the end-to-end automation with very low or no manual effort at all, and comprehensive governance and compliance policies established, and also centralized MLOps pipelines, and also advanced observability and continuous implementation. So this is like a extremely sophisticated MLOps pipelines which are built to look at monitoring aspect of it. When we deploy, during the deployment or during model deployment testing, we have metrics baked into the whole pipeline, and all these checks around governance and compliance is also baked into the whole end-to-end pipeline. And let's talk a few details about what are the primary obstacles to ML success. I think some of the primary, if you look at some of the charts here, so I think you can look at organizational silos. I think for any success, I think it's extremely important for teams to collaborate and work as a unison for its own success. I think that is extremely important. So at least in some of the metrics, some of studies, we can see almost 73% of the ML initiatives directly are linked to inadequate failed ML initiatives because of inadequate collaboration and governance. There are other limitations we can think of. Infrastructure is not strong enough to is not built for what we want to serve for customers, and also not having enough monitoring. If we don't have monitoring, we don't know what's going on, right? So I think it's extremely important to have a robust monitoring. Again, data quality issues, mostly similar. I think garbage in, garbage out. Having that really quality data to train on or build those models is also an extremely important aspect of it. And also the lack of standardization. Without having the standard tools and technologies and also the pipelines to deploy and models at scale, it becomes extremely difficult. And also governance gaps. Having those governance gaps is also extremely important. And also looking at some of the metrics here, considering some of these links, like we can think about like 56% of production ML failures are directly linked to data quality issues. As I was mentioning, data quality is extremely important in a production AML kind of a systems in a way, right? Similarly, for insufficient monitoring, almost like 38% are linked to insufficient monitoring. Lack of standardization, 45%. These are like ballpark numbers that we have gathered. This is also showing how important to have these systems in place so that we are more building towards these known obstacles so that we can build for success in a way. So that's like what I want to cover for this slide. The next important thing is what are the architectural patterns that we can put in place. We can build a system which is really robust, right? The first important thing I want to touch here is modular component architecture. So the more like decomposable components, right? Every component, again, decomposable components, core construct is component should be able to iterate on its own. You can deploy model, not only model, anyway, like all the MLOps pipeline has multiple steps or multiple components to it. Every component should be able to be iterated on its own and also improved, all this good stuff, right? And the other important thing is centralized feature store. For any model development pipelines or model development teams, features are the most important things essentially, right? These are the things that are baked into the model and used for predictions and stuff like that. So having that consistent centralized feature store is extremely important. So that also provides guaranteed consistency for training and inference environment. So that is extremely important in a model environments in a way. And the other important thing is like reproducible training pipelines. Again, so we really want to deploy models at scale and also want to release new models as frequently as possible. So we're giving the best to our customers, right? Looking at that as a metric, having that reproducible training pipeline, so that a lot of manual efforts can be avoided, and a lot of these things can be having that consistent pipelines and also reproducible would help eventually in accelerating the development postage in a way. And the other important thing is also having automated validation pipeline. So at every stage, having that model automation in terms of having those validations at every step of the way is extremely important as we scale our systems. So let's talk about how do you build a robust MLOps pipeline. Having that model lifecycle deployment, model lifecycle management, essentially how do we is also extremely important in terms of this helps almost deliver 3x better model monitoring. At the same time, reduces production incidents by almost a half, right? So what are the various things that we usually look at when we think about model, right? So we have data engineering, which provides all the essential data points, whether it is like data required for feature engineering on all those other aspects of data. So once we have data, I think the next important part is like model development. So the primarily ML engineers or applied scientists who takes this data and builds some robust pipelines where we train ML models to come up with the robust models for any use case essentially. And the next important thing is like now once a model is developed, other important thing is like we have to validate it whether it is working. Now models are usually trained on training data set essentially, then we have to validate it how it is working on the real data set in a production data set. Are we seeing the right kind of predictions, or if it is not performing as good? It can be various other things. It can be model accuracy kind of information, or it could be like performance in production and stuff like that, right? So having that validation is the step that is extremely important. And also eventually once it covers all the validation aspects of it, then mostly like deployment of it in production and scaling it. And once we deploy it in production, the most important thing is like monitoring for it. So for the first thing is that now we deployed the model, and so once we deploy the model, how is the model performing? How is the predictions look like that are generated by model? Are the users that are using our systems, are the sentiment is positive or they are not so much or negative? Having that feedback signals fed back into our systems would help us improve our models tremendously in the future. So having that end-to-end monitoring and also feedback systems that can be used for model deployment or development deployment is extremely important in building any MLOps pipelines. So the next aspect I want to touch upon is so technical implementation of model validation framework. So how do we validate? What are the things we want to actually validate? So again, from as I was mentioning, now we have a model that is developed, and now we need to think about what are the things we need to, while we are building these MLOps pipelines, what are the testing things we need to build, right? So the first important thing is data. Everything starts with the data in ML, right? So I think we have how good data that we have would determine how good our models are, garbage in, garbage out. So it's extremely important to start with ML, primarily a data validation. Whatever is the use case, we need to have some kind of a data set. Having that while we are creating this data set, having that schema enforcement, also having that distribution checks, drift detection and stuff like that. So to make sure we have a very clean data is the first step of any validation framework. The next thing we want to think about is like now model is deployed in production. So the next important thing is like how do we measure the accuracy? So how good it is performing this production, and also aligning with some kind of a key performance metrics, right? So that is other aspect of validation as well. The other thing is like the now we talk about operational things. Now the other operational thing is the latency testing. So even though the performance or accuracy is super good, but the thing is if the model predictions are taking too long, or if it is taking a lot more time, the customers may not like it, right? So I think in this world, users would like to see fast responses. The other important aspect we need to validate is like how fast it is providing all these predictions, and that are providing the timely predictions is extremely important as well. Again, other aspects like it's not only latency metrics, and also you look at resource utilization, throughput analysis, all those good stuff. And the last thing I want to touch upon is like ethical validation. Is there any bias that is coming out of this model? That is one side of the things we need to have a validation as well. Is the responses more consistent or is it fair? Is also an extremely important metric we need to capture or test our models against. So what are the best practices here, right? So having that clear acceptance criteria with pass or fail thresholds for each validation step is extremely important while we go build these production systems. And also having those integrated into CI/CD pipelines, we don't want to make it manual, right? So I think we want to build them into the consistent CI/CD pipelines that can actually enforce these checks at runtime, and also having that history to track how this quality of models or how this model deployment and validation delivery is happening is also very good indicator for us for our maturity or on how we are progressing as MLOps teams, right? The next thing I want to touch upon is technical implementation. So there are a few aspects I want to touch upon for any CI/CD pipelines or CI/CD systems. Continuous integration, continuous delivery is an extremely important aspect of it. So for in case of continuous integration, again, a few things I want to touch upon: model quality validations during the integration stuff, and also versioning model artifacts during building the models, artifacts, having this versioning in place and right metadata attached to it. And also dependency environment management is also baked into the same process as well. The other important thing I want to touch upon is like a continuous delivery. So when we are deploying these models at scale into a production environment, usually it's containerized. There's a lot of other tools that we usually use, like it could be Triton server, various other things that we use, Docker containers, and various other things that we can use. But this is one thing we need to also keep in mind. How do we build those consistent containerization of a model serving framework, right? The other thing is also environment specific configurations and IaaS infrastructure as code deployments as well. Other important thing is like canary or blueprint deployments. So when we want to deploy the model into production, there are various deployment strategies that we can look at. For example, if you want to do something like canary deployments, it's more in a production systems. We may expose some percent of production traffic to this new version of the model and see how it is performing, and based on metrics that is emitted by this new model, we can either promote it to higher percentage of production traffic and eventually take 100% of our production traffic. Or blue-green deployment is creating a simultaneous green environment or a blue environment along with the production environment and see and pass through some of the traffic to this new model and see if the metrics are looking good. We promote the new version green deployment into a production version. So those are like different methodologies that we primarily use in case of microservices deployment architectures. Again, once we build and deploy, the other important thing, as we have talked about previously, is also like monitoring, right? Having this real-time performance metric, and also other aspects like drift detection and alerts, and also feature distribution monitoring is also extremely important. And all these are correlated to also see how this is all correlated to business metric correlation is also extremely important. Having that consistent monitoring, it gives a better view of how the system is performing, what are the things that we can improve upon as well. Yeah, the other thing I want to touch upon here is like A/B testing of models. Again, I think ML models, I think this is a very well-known framework that is used in AML teams, is having that A/B testing. So basically, enterprise with automated A/B testing will achieve almost 40% faster model iteration cycles and also 25% higher performance improvements compared to manual testing approaches. So what is actually A/B testing? So it's mostly having that when we have two different versions of the models, exposing a customer to both the versions of the models and see the user sentiment, which is performing better in terms of giving, whether it is like a recommendation systems or any kind of use case that we're trying to build, seeing which model is performing better and also trying to use those signal to promote either of them is like testing is what we usually call about, right? There are a few aspects to it. Again, traffic allocation, dynamically route user traffic to model variants. Again, it could be configurable. Similarly, performance measurements accurately track across both metrics and technical metrics. So as I was talking about, latency and all those other things will come into technical. Business is like how is a sentiment look like? Is it performing positive, negative, and all those user aspect of the things, right? And also other thing is like statistic analysis. Just think about, again, mostly about data-driven deployment decisions, right? Rigorously having that analysis is also extremely useful in such kind of systems. So the other aspect I want to talk about here is like now we have talked about what are the challenges, what are the things that we can put in place, and what are the extremely important in terms of testing and some of the testing framework like A/B testing and stuff like that, right? So now functionally, in terms of how do we build this in such a way that it is built for success. There's like primarily in any ML teams, we have like data science team and also ML engineering team. So two different teams, and also the collaboration of both of them comes to a MLOps excellence. So essentially, these are the people who have mixed knowledge of both data science side and also ML engineering. So these are the core collaboration that helps build some of the typical aspects of MLOps pipeline. So a few things I want to mention here is like cross-functional. Like in MLOps teams are extremely important in terms of working across teams to build those consistent end-to-end ML products, and shared accountability model in a joint ownership. It's a joint ownership between ML performance, operational health, business outcomes. So it's not one team's responsibility or one person's responsibility. It's a joint responsibility. And also the other thing is also MLOps Center of Excellence, like critical team having that best practices, governance frameworks, and also helping them do that self-service MLOps is an extremely important thing as well. Then I want to touch upon few aspects of cost optimization as well, right? So I think all the GPU hardwares are expensive. For building any MLOps pipelines, I think these are few things we need to keep in mind so that we are building in a much more efficient way. Key cost drivers, looking at compute cost, as we all know, I think compute hardware, all the GPUs are extremely expensive. Definitely need to consider that, and also data storage and processing, the data pipelines, feature stores, ML pipelines, how do we generate this data is also the next aspect of where the cost could come in. And the tools and platforms, MLOps pipelines and monitoring systems, and also specialized tools that help us build this monitoring at scale is also something we need to keep in mind. The other thing is like operational overhead, like system maintenance, support, incidents, and all those other things, right? Few things I want to touch upon in terms of operational strategies, resources, auto scaling. I think a lot of cloud providers provide this out of the box. We should be able to auto scale the infrastructure to dynamically match our workloads demands. That's the request grow. We can have those automatic knobs in place so that we can get those auto scaling, right. Model efficiency. These are few ML concepts that we usually use, like model pruning, quantization, distillation, to reduce the footprint and the size of the models, and also probably get similar or close to good similar performance in a way. And the other thing is like process automation. Having that complete end-to-end automation is extremely important in terms of our strategies as well. Enterprises that actually implement these strategies achieve definitely have significant cost reductions, and also most importantly visibility, right. I think where how much is going on is also extremely important while we're building this system, so that we know where to increase our spending and how we can optimize is also an extremely important decision that we can look at. Since we have talked about a lot of other aspects of it, now I want to touch upon what is the future, right? This is an evolving space which is rapidly growing. How do we build systems that can looking at the future, right? So I think we're just making sure that we are building for the future. So a few things I want to touch upon is like MLOps observability, gaining that insights into the model behavior. As I was speaking, is having that complete monitoring and end-to-end metrics is extremely important. That is one thing which we need to keep in mind. And also having that AI governance, implement frameworks for responsible AI deployment. Responsible AI is extremely important nowadays. And also having that auditing, bias detection, compliance controls is extremely important as well. Federated learning, again, this is more like having that models being trained across decentralized data sources. Again, an extremely important aspect, and also obviously improving privacy and security. AutoML is also like autonomous continuous model improvement. Again, looking at feature selection, getting the feedback, permanent tuning. It's like a complete cycle of how do we use that end to end to actually improve our models at scale is something that we can keep in mind as well. Key takeaways I want to talk of briefly about key takeaways or high level. Start with clear governance. I think there are a few things like establish that robust governance and model lifecycle management practices. Make sure that we have that solid foundation for ML initiatives. Build modular architectures, making sure that these are decomposable units. You can build them, deploy them, scale them independently. So those are extremely important as well. Automate ruthlessly everything. I think extremely important. Automation is very important as we scale our infrastructure, systems, any manual process, look for opportunity to automate. Integrate teams. Again, the teams, if there are silos, it's extremely important things work in unison. Have that consistent expectations or collaboration with each other is extremely important in this kind of systems as well. Again, looking at some of the statistics, we can see like enterprises with mature MLOps deploy almost 5x faster and also achieve 60% higher model performance in production. Extremely important statistics there. I think having these tools and processes and building these consistent pipelines can definitely improve these systems, ML systems at scale. Yeah, I think these are all the things I want to cover for this talk. Thank you very much for tuning in. Have a nice day.